Welcome back to the panel discussion, Data-Driven Decision-Making in Government, sponsored by Vion Corporation here on Federal News Radio 1500 AM and federalnewsradio.com. Our guests today are Duncan McCarthy, the Technical Executive at the National Geospatial Intelligence Agency's InnoVision Directorate, Mark Elbert, the Director of the Office of Web Management at the Energy Information Administration, and Richard Breakiron, the Senior Director of Cyber Solutions at Vion Corporation. I'm your moderator, Tom Temin. And Mark, I wanted to get back to you as we start again here on the infrastructure issues and how you manage and store all of this data, and also the metadata and tagging ID qualities that data has to have so that it's useful.
Right. Well, thank you. So in EI, I think it's our size of our data is probably a good order of magnitude below somebody like the National Geospatial Agency. So much more conventional methods are working well for us, but I think we have big challenges in terms of the tagging and metadata, and we haven't done as well a job as we could have in the past. So there's the idea of assigning metadata to individual events or points, to series, to data sets, and then particularly what are the relationships between those data sets so that when you look at a particular piece of information, what's the surrounding information? And that's a big challenge. I think we're making some progress on it, but that's where we're putting a lot of emphasis right now.
And how fine-grained is the grid that you look at in terms of getting data from different points? And it doesn't get down to the household or to the appliance at this point, but could that be something in the future?
Well, currently we're primarily surveying the producers. I think one big challenge we're trying to crack is for example, as electricity generation has become more distributed. So we used to be able to survey the generation plants and have a pretty good idea of what was happening. As you have residential solar, how do you get an accurate idea of what's being generated there because it's not being measured in the same way? So there's some challenges to that, yes.
Is anyone measuring that? I've just noticed these things popping up all over the place lately, houses suddenly covered with panels. And does anyone collect that data? And at some point, could that aggregate up to the Energy Department, but not necessarily have you gather it?
Right. I think the utilities play a key role in that. This gets a little bit more in the subject matter expertise than where I am. But I think that going through the utilities, because they have the net metering and working with them, there's also various ways you can estimate it based on installations. There's even some efforts to do rooftop geospatial analysis. Some of the labs are looking at that to come up with an estimate of the total number being generated. So it's a good problem.
So you have almost a federated model of the way the EPA works, just to make an analogy. They don't directly gather emitter data and source data, but it's collected locally, but kind of feeds up into them at some point.
Right. So when we run a survey, we're very much aware of the burden on the respondents. So we go through a process, and typically we work with industry to have a low burden. So obviously, going out and reaching out to the individual homeowners would be too much. So we'd have to work through industry to come with valid estimates for that.
Or maybe you could get a question on the Census Bureau if they'd let you add one. They would probably for $1 billion. All right, and Richard, looking across again the government-wide view here, how are people starting to manage their data in terms of storage and infrastructure? Has the cloud yet come into this big data era, or is it still mostly email?
So what we're finding in our personal experience in going out to industry and going out to government is the cloud is a great concept when it's your own personal data, but when it's actually organizational data that has some type of implication for intellectual property or has some security ramifications, you have got to overcome the security discussion up front. And if you don't have a secure solution, people willing to move up to a cloud just to save money is not going to meet their needs. So the first discussion we always have is an on-premise. So uniquely, you'll find some businesses are willing to come on-premise and some are not. If you talk to Amazon and Microsoft of the world, their business model is no, come to us, and that's how we're making savings, and that's how we're delivering a very effective enterprise solution. If you talk to agencies like NGA, NSA, CIA, et cetera, they really want you to come on-premise because they want to be able to manage control of the security environment of their operation. And so a lot of companies are doing hybrid. When you look at the DoD, They look at all their public facing. When I'm advertising and trying to recruit somebody, that's a public facing service, and there's no real threat to compromise. So I'm willing to have that hosted in a commercial cloud, save some money. But on the backside, I want a integrated capability to work with an on-premise cloud. So that combination is what we're really seeing as a big thing.
So an on-premise cloud could be several models. It could be contractor-owned, government-operated. It could be the opposite of that. It could be contractor-owned, contractor-operated. But then do you really get the scalability up and down and some of those other qualities that are attributed to the cloud if it's on-premises and it's just there?
So I'll give you a couple different answers to that one. So the scalability of the DoD, it works really, really well because, believe it or not, when you put Army, Air Force, and Navy together, their security issue is the same. So if you put them in a hosted cloud, when general administration has gone out and surveyed how much of a server or storage array is being used in any of those services, they find less than 20% is actually being used. When you consolidate them into a DoD federated cloud, guess what? You now get sizable returns, and you have enough scale to do that. When you do it to the .gov level, you'll find some interesting issues. Things like Bureau of Indian Affairs wanting to have their data hosted at a DoD site where you are scanning that DoD site for compromises in security and insider threat. You'll find that there are certain treaty agreements that says, no, you can't do that. So you always have to understand what the environment is and make sure that you give the directed capability. But no, I think there's a huge scale issue on premise that can be overcome by some of the major organizations. Department of Energy might be a little bit different. The last piece I do want to talk about a little bit from an infrastructure that Mark talked about is when you look at infrastructure today, you need to also consider industrial control systems, ICS, and SCADA systems you'll hear a lot about. And again, there's a security issue associated with that. So we're always working with government to figure out how do we secure if a traffic light has an IP address, and many of you have seen the Bruce Willis movies and all the other dramatic, some of the cyber movies and cyber shows that are on TV now, the ability to actually hack into those and actually control industrial control systems and SCADA systems remotely is actually pretty amazing, and it's also pretty scary at times. So these are the other things we work with the government on as we implement any solution for data management. Security first.
All right, yeah, so let's go to Duncan on that. First of all, about cloud versus on-premises versus public cloud versus your own facilities. What is the strategy there? Do you have a strategy? And what do you see as your 2B model, say, in a few years for these massive data sets?
Well, I think the biggest strategy of the intelligence community is, of course, just to air gap it, right? I mean, we'll have our own internal networks and our own, a contractor-provided, contractor-run facility. However, we do levy requirements on that contractor that they be U.S. persons and things like that on the inside. And so, but there's three levels of network, right? There's the very highly secure network. There's the secret level SIPRnet, and then there's the unclassified work. And the unclassified work, we are really very able to make use of things like the FedRAMP process to host all of the data that we're going to need to be able to provide geospatial services to the unclassified user for things like disaster response and things like that.
And moving up a level, then it would stay close to the vest.
Yeah, obviously, as part of the intelligence community, we're not going to be. We don't share too much outside.
Right. And I've tried, and I can't get through it all no matter what I do. And Mark, at EIA, of course, you're looking at the grid, and that really is a giant SCADA system in effect. So do you also pay attention to the cyber practices of the people whose data that you're watching and gathering from?
So we operate under CIPSIA sensitive information, which protects statistical information, respondent level, because there's lots of important business intelligence. We're typically not operating at the SCADA level, so we don't have that concern. I did want to go back to a point that Richard talked about in terms of the utilization of the servers. So I mentioned earlier that we're currently not moving, and it could change in the future. We haven't moved a lot of our processing into the cloud, but in some ways the cloud's come to us. So what's happened in recent years is the virtualization. I think it started with the major providers, But now the tools are there, so even if you do choose to maintain, for your security reasons, your own internal data center, you're still able to capture a lot of the benefits of the cloud in terms of virtualizing your servers so that you get your utilization up, so you don't have a server for every particular task. And you can get some efficiencies, and then you can start making more intelligent choices about where do I want to go, who has what capability do I need, as opposed to going just for that one reason.
And if you virtualize an application in a server, what about the data that might be used by that application that's part of a much larger set that might also be used for other applications? How does that all get divided?
I mean, it has to do with your data storage strategies, where you put it, how you share it. But just simply talking from an efficiency point of view and lowering your footprint and costs, it's been a big driver.
Okay.
So I can amplify a little bit with what Mark's been talking about too, is when you do an infrastructure as a service model, notice that the original amount of either servers or storage in a virtual manner can be scaled to demand. So rather than, as many government organizations sort of do, hey, I finally got my contract, I'm going to buy as many servers and storage, I don't care how much goes unused because I never want to go through that contracting process again. When you do it as a service, you can scale it, and you basically say, you need 100 terabytes today? Okay, we'll start out there. And you only pay for what you use. So industry is very good now at saying, hey, even on-premise, I can come and do it as you use it, and I'll give you a notice. Hey, same way you get a cell phone notice on, hey, you're at 80% of your minutes or your data plan, you might want to consider a different plan. I can scale up in a very logical fashion that's very, very cost-effective. Get a lot of benefits from it. Not only do you scale up only when needed and you only pay for what you use, but you get to scale up to the latest technology. So, and you don't have licenses and hardware that are sitting in warehouses or sitting even spinning disk on a floor, eating up energy that really isn't being used to compute. So a lot of good advantages, and all government agencies are very sensitive to now.
And how does the brokering come into all of this? Because in a sense, brokering virtualizes the cloud choices that an agency might have to make. We're starting to see some good policy coming around there and some good practices. Open source development of cloud brokering services are even out there. What do you see going ahead in that direction?
So again, I think you always, when you're in industry and government, you always want to trade off between open source and open standard. You always want to have open standard, and even your open source has got to be made to an open standard. The real distinction, as far as we're concerned from a brokering perspective, is do you want industry to maintain the open standard software and hardware for you, or do you want to bring that in-house? In government, we always find it's a hybrid. Duncan's mentioned it and Mark's mentioned it as well. There are systems that are sensitive and require a different manner and treatment, and so you always find a hybrid solution. They are very sensitive to, hey, that's purely unclassified and not sensitive, and yeah, we want to get the best rate possible on that. So you broker it based on each situation and each mission area. And industry's coming along the same way. It's interesting to, as I go to industry, I actually take more government solutions with me to industry, ironically, on certainly the security side. The security side of the government is far in advance right now of a lot of industry.
All right, so Mark, what is your 2B model in terms of storage and hierarchy, and where and under what ownership the facilities are as you go forward?
So I think EIA is experimenting right now with moving a lot of the front-end acquisition into the cloud. And using having it hosted outside the building. Security has definitely been a challenge for us, to be honest. For the back end right now, for the processing, it's worked pretty well to keep a lot of that in-house. It's an evolving situation. So what I say now could be very different in 2 years. The technology and the landscape is just changing so fast.
All right, and so it seems like NGA then, Duncan, is going to pretty much stay close to the vest in terms of in-house facilities for the classified, highly sensitive material.
No, it depends on what you mean by in-house. We're working with
Government
the DNI.
owned.
Yes, we're working with the DNI within the eyesight environment, the intelligence community, and information technology environment. So we'll be within that.
And is the eyesight community, is that available to other agencies outside of
It's available to
IC?
all 16 kind of member agencies of the IC to some degree or another.
But like Health and Human Services couldn't say, hey, that's pretty secure, let me in there. No.
Yeah, unfortunately, I don't think so.
All right. Well, we have a couple of minutes left. I want to begin the discussion of really bringing this together with how you get value out of the data. We've established how much there is, where it comes from, how it's growing, how you manage and store it and tag it and make it identifiable. But now we want to get into how you make it valuable and the kinds of analytics tools. And we have just a minute before the break. But Mark, why don't you begin by telling us what you're looking at in terms of data analysis, how it was done and what you're looking at.
Probably about the last 3 years, we've had our big sea change from producing fairly static reports and pages to trying to create interactive tools where you can query data sets. For example, electricity, we have single-page applications. You can look at any of 500,000 time series in it. You can chart any of them. You can map them. You can start with the top-level statistic, drill down to the state, drill down to the plant, actually see that plant on geospatial map and start moving around the map. So we started to also tie together the statistics with its geospatial properties. So virtually everything that we collect, there is a place and a time it's collected. So you can organize around time, you can organize around space, and those are very powerful principles that make it much more valuable to decision makers.
All right, we're going to leave it right there and come back to that point when we take our break right now. Our guests today are Duncan McCarthy, the Technical Executive at the National Geospatial Intelligence Agency's InnoVision Directorate, Mark Elbert, the Director of the Office of Web Management at the Energy Information Administration, and Richard Breakiron, the Senior Director of Cyber Solutions at Vion Corporation. I'm your moderator, Tom Temin. This is Data-Driven Decision-Making in Government, sponsored by Vion on Federal News Radio 1500 AM and federalnewsradio.com.